Hi, my name is Shah Khalid Khan. I'm a PhD student at the RMIT University, Melbourne, Australia. Today I'm presenting a short video for one of my paper which is available online in the Accident Analysis and Prevention. The title is the Cyber Attacks in the Next Generation Cars, Mitigation Techniques, Anticipated Readiness and Future Directions. The authors are me, Dr. Nirajan and Dr. Peter. They both are the faculty members at the School of Engineering, RMIT University, Melbourne, Australia. Cave cybersecurity is cave communication is the primary area vulnerable to cyber attacks. Therefore, it needs a regular and efficient approach in the form of cybersecurity. Any incident or sequence of events which impact any of the 7 KPIs of the communication data flow, which is the availability, authentication, reliability, confidentiality, robustness, integrity, and trustworthiness, can impact the cyber security. It can impact both safety and non-safety issues, and it happens we have a case of the Fight Chrysler. There are some solutions for the cyber security in caves, but which are mostly focused on the cyber physical system, which is not practical for the caves. The reason is that cave need to spend more time in the field. There are some hardware limitation in the caves. Caves need to operate in the real time. So many of the private identifiable information are linked with the caves. And again, in implementing any firewall, these need to be taken care for the automaker intellectual property, and memory and computation constraints are also there. Therefore, the cybersecurity of caves cannot be improved by hardware or software. It's the property of the entire system components. That requires a methodology based on the system approach. And this is the problem statement which is the focus for this study. So in terms of setup, first of all, we focus what are the key avenues which are of high importance in the assessment of the cyber security in the caves. So the first important avenue is the cave communication framework, which is the primary vulnerable interface for cyber attacks. So cave communication framework can be broadly classified into two. One is the in-vehicle communication, which is in the form of the automotive bus system, or the sensors communication, or the electronic control unit communication. And vehicle to everything communication are in the form of the vehicle to vehicle, vehicle to infrastructure, vehicle to IoT, or we could call all this one as the vehicle to cloud communication. Wireless technology used for this purpose are DCRC, cellular network, 4G, 5G, and the potential 6G as well, Zigbee, ultraviolet band. These are the wireless technology used for this communication purposes. Now, based on this communication purpose, what are the cyber attack vectors in caves in terms of the in-vehicle communication? So any cyber attack can be happen in the form of the intra-vehicle communication, which is the LAN, CAN, MOS, FlexiRay, and Ethernet, or in the form of the sensors communication, the one in the right, or in the form of the electronic control units, the one in the green. And now the cyber attacks in vehicle to vehicle communication. So any because this potential V2X communication can be used any of this wireless technology. So any vulnerability in this technology can lead to cyber attacks. Physical access can also lead to cyber attacks. Physical access or proximity access attacks can be classified into 4. One is the element access. The other one is the proximity access attacks in the form of inaudible voice commands and passive keyless entry. And the other one is the legitimate access in the form of the diagnostic ports, or illusion attacks in the form of the traffic sign spoofing or projecting images of the fake road signs via drones. Another important avenue in combating cyber attacks is the cave communication supply chain. As we see, there will be different layers providing parts to the automakers. So all these chains, in every chain, there is need for the trust provision schemes. The trust model will enable different stakeholders to inject assets at different stages. And importantly, all the OEMs or the automators need to commit to third-party audit commitment. Another important avenue is the human factor in the cyber safety of the caves and the use of the criminology theory. As we already know that human weakness is the most likely explanation of the successful cyber attacks, and usually the human link is the weakest link in the cyber security, and cyber security is as much strong as the weakest links. So psychologists and human factor researchers can augment cyber security in caves by exploring how to reduce the risk of successful cyber attacks. And also there's the need to study the motivation and characteristics of cave cyber attackers. And again, criminology theory could be of importance in mitigating cyber threats. Another important area in combating cyber attacks in caves is the regulatory laws and policy framework. As we know that the technology is innovating, but still the laws are far behind. So there's need for the policy readiness, clear and concise policies for cave operations. There's need for the stringent and up-to-date regulations, and also there's need to be clear formulation of the liability readiness. For example, when the caves in level 4 and 5 are operational, so the control will be in the computer. So who will be liable? To decide this, we need it needs a clear sort of formulations. And finally, all these activities need to be taken as integratedly, as the development are happening in the automotive, electronics and telecommunication industries. The need for the value creation of networks and closing the gaps between the different stakeholders. And another important issue is that currently, even till now, the cyber security is deemed as a second priority in automakers industries. The first priority is the performance and the safety. So the priority need to be enhanced. So in future directions, if for combating cave cyber security in a holistic way, these need to take care for the cave communication framework, and need to look at the physical proximity access attacks, mitigating it. The cave supply chains need to be in the focus. Human factor and the criminology theory is of importance, and there is a need for the updated regulatory laws and policy framework. And finally, all these activities need to be happen integratedly.